Now, as a C++ developer, you have some options, and especially since Visual Studio 2005 was released, you now have one more option that you didn't have before with C++. Now you have two basic choices, and I've mentioned these in a little bit different format in the C++ or C++ CLI videos. It was a two-parter. You can go look those up elsewhere in the course. But your two basic choices as a C++ developer are to write native C++ code, and you have some options there. And again, what are we going to do there? We're just going to write some C++ in a standard form. It's going to compile down to machine level code, and it's going to run on the machine. This is very fast, very efficient, somewhat dangerous, all right? And then there's managed C++ options that have come our way thanks to the .NET Framework in Visual Studio 2005. And on the native side, let's talk about your options. With native C++, we're talking about something you'll also hear it called as ISO or IEC C++, and you'll also hear it called unmanaged C++. Now keep in mind, Microsoft considers any code that's not managed by the Common Language Runtime, or another way to say that, it's not managed by the CLR. Any code not managed by that is considered unmanaged code. Now, if you're a kind of a newcomer to the industry and you're reading it, this is like this great unwashed code that's going to do great damage. That's not what it is at all. It just simply does not get governed by the Common Language Runtime. Now, this runs directly on a computer. You can access the Windows API directly, so you can do Windows programming with it, but you access the Windows API directly with the C++, and this, by the way, provides you with the ultimate in performance. So when you've got to write something that runs really quickly, really efficiently, native C++ is probably going to be the way you want to go. Now, if you want to combine native C++ with some of the Windows graphical user interface type stuff, one choice you have is to write your code in native C++ and then use MFC, which in English means Microsoft Foundation Classes. And MFC simply encapsulates the Windows API for GUI, or graphical user interface creation. So this is a way to write the code behind the graphics in native C++, so it's going to run really quickly. But all of your forms and so forth, the Windows API, are accessed, and you get your graphical user interface creation. So the MFC provides the graphical layout for you, and native C++ provides the functionality. Now, let me just warn you, depending on the developer that you talk to, you mentioned that you're doing native C++ and MFC, and that may start throwing furniture around the room. There are those hardcore types out there who say native C++ is the only real computer coding out there, all right? Just nod and smile and don't make any sudden moves around these people, all right? Others will swear by C++ and MFC. Others will call you all kind of horrible names when they find out that you're talking about doing that. Now, the one that will really raise the ire of a lot of people is when you talk about managed C++. Now, managed C++ is when we basically build a Windows application very similar to what we would do with C# or VB.NET. The code's written in C++, but it is completely managed by the Common Language Runtime. Now, the advantage of this is the memory gets managed automatically. It's much, much harder to create memory leaks and memory problems. And this is a common source of errors in native C++ applications, because memory management can get hard to keep up with and manage properly. Now, it does a lot more than that, but we're going to stop there. But keep in mind that managing this memory, using garbage collection and doing some other things, does add overhead to the program execution. So if you're looking for the fastest, most efficient, smallest footprint code that you can get, C++ native is going to be the way to go. If you can deal with a little bit of overhead and you want the .NET Framework to take care of your memory problems and challenges and so forth, then managed C++ is going to be the way to go. So you are going to negatively affect performance here, but you're still getting something for that. So if you can live with the performance hit, managed C++ is a great solution. Now, let me just remind you one more time that managed C++ means that when we finish writing our code and we compile it, It does not go all the way down to machine language. It's going to compile to what used to be called MSIL. They now just call it IL, but that stood for Microsoft Intermediate Language. And this again provides a lot more management, code security type functionalities. And if you want to understand exactly what it's doing, just go grab you a good book out there and dig a little deeper into the Microsoft .NET framework for more information about this. Now, this is not a .NET framework course, so I don't want to go any deeper than that about CLR or anything. We just understand those are your options. Now, you have one more option that I haven't mentioned, and that is to write code where part of the code's managed C++, part of it's native C++, and you can mix and match these within your applications. It does bring up some issues about sharing object data between the two versions and all that, but that's a whole nother thing outside this course. But just understand you've got a lot of options with C++. I just want to kind of make sure you understand a little bit about what those options are so you don't get confused when you see all these slashes and pluses and things that are going to show up out there in the documentation. Now let's talk about the structure of a C++ program, and here we're talking about pure native C++. Now understand that when you're coding in native C++, there have been no provisions made for a GUI or, in English, a graphical user interface. All you get is just pure code that's going to run and function, and it's going to function at some command line type environment. Now a C++ program, when it's all said and done, is simply a collection of functions. Now a function, you ask, and I answer, is a self-contained block of code that has a unique name. In other words, we're going to write some lines of code, could be 2 lines of code, could be 2,000 lines of code, and we're going to give it a name, right? Get data, feed dog, whatever we want it to do. We're just going to give it a name, and then we're going to call that name, and that's called invoking the function. And just by referring to that name in code, it goes, it finds all those lines of code, and it runs every one of those lines of code in order. So you cause all the code in that block to execute. And we'll talk about a block in a separate video here in the course. Now, when you start a C++ program, it has a normal starting point, but since we don't have a graphical user interface like we do in some of the like Visual Basic.NET or Visual C#, we don't have a form that we point to and say, okay, this is the starting form. What we do have is a function that's called main, and you see the name right here. You see it's main and open parentheses and close parentheses, the main function. Now you'll have one of these in every native C++ program, and any other function in the program can trace its origination back to main. You know how we can get on the internet and start chasing down our ancestry? Well, any functions in a C++ program, if they were to get on the internet and start chasing down their ancestry, it's always going to end up back in the main function. Now, you can have a function inside the main function that calls another function, which can then call another function, which can call another function, and I'm sure you see a pattern developing here. So our program can get quite complex. It can branch out many times, but understand it always starts in that first original function that's called main. So each function then provides its own specific functionality. Using the word function in various forms of it a lot here. All right? But the bottom line is I can create these separate little sections of code, give them a name, it becomes a function, and then I can call that set of functionality anytime I want to. Now this is pretty cool, because each one of my individual functions can be tested individually, and they can also be reused. So if I write a function that connects to a database and makes that database available to me for reading or writing, I can put that into a function, and then I can reuse it from 50 different places in my program. I just keep calling that same function, and I might even want to pass something unique to it. We'll talk about all that stuff later on in the course and do some examples. Okay, but that's the basics that you need to understand about a C++ program structure. Everything starts in that main function. In this very short video, I want to show you a very simple diagram that will help a lot of people, especially the new ones, not new people, but new to C++. But it'll help you understand the way C++ is operating. And this is out there all over the internet in a bunch of different forms, but I just wanted to include it here to help you if you're new to this idea of working totally out of code, because for most of us nowadays we start off learning coding in something like VB.NET or something, and we're using visual windows and forms and so forth. So we've got this main function here, and this is going to be the starting place of our C++ program. Now in this instance I'm creating an application that's going to be used by a veterinarian. So people bring their cats and dogs and what other weird pets they have, like snakes and spiders, in, and we're going to treat them. Well, the program that we're going to be running to do that is a C++ program, and you'll notice that it has a main function. Don't worry about this integer designation right here, but got a main function, and the first thing that you see here is that when we fire up the program, it's going to jump into main and then begin to work its way down and take care of the code that we have. Well, the first thing it's going to do is find this function here called TCB, because the first thing we need to do is take care of business. And this is a little Elvis Presley lingo here, but we're going to take care of business. So when someone walks in carrying their little dog, the first thing we need to do is find out some information about this client, about the animal, and so we're going to call the TCB function. Now somewhere out there in our code, outside of the main function, we have created another function, and this one, notice it has void in front of it. We will talk about that later in a separate video. But this function is called TCB, and you'll notice it has its own braces. We'll talk about those later. And we've got a little comment here telling us that we're going to put some code in here to locate or input client and animal information. We want to know who the clients are because they're going to pay the bill. We want to know who the animal is so that we can keep records on them. And so this particular function will take care of that. And then notice return. Once our code finishes running, it completes, we're going to return control of the program back into the main function, and then we move down to the next one. And the next function that it sees is treat. Program figures out, hey, wait a minute, that's calling another separate function. So it goes out and finds that one, and we're going to provide care. And from our standpoint, some functionality would happen here for us to record what we did to the dog. We gave it a shot, we put a splint on it, took care of something that's swollen, or just whatever we're doing. Maybe it's just a checkup, okay, if you get checkups for your dog, I don't know. So anyway, once that happens, and we would write code inside this treat function, it would return control back to the integer main function, and then it would jump down to the bill function. And this is the good part as far as we're concerned, right? For our business, that is. I mean, we care about the animals, but we need the money also. So there is a bill function that's been written, okay? And notice we're going to bill the client, we're going to create an invoice, we're going to collect money, and we're going to make a record of that, whatever's going on, and then that will return information back into the main function, and then the main function will complete and it will return a 0. Now where is it returning this information to? Well, this is going back to the operating system that's running this C++ program. Got a lot of options there, don't worry about it right now. But that's the bottom line. Now keep in mind, inside any of these functions that popped up out here, TCB, treat, or bill, I could have had a call right here to another function, okay? Because if I want to print an invoice, I could have had a call to a function called print invoice, and it would have jumped out to functionality that causes something to print. So what you're going to have basically are leapfrogging from one location to another, from one function to another, taking care of whatever actions we need to have taken care of. So that's just a real quick diagram of how the program's going to run. And always, when you're looking at C++, find main, and that's where it's going to start. It's going to jump right into this function, this main function, and then it's going to start working its way down. All right? It's going to leave the main function, do some things, get passed back in, and just keep doing that. Okay? So that's just a real simple diagram of how your C++ program is going to actually be carried out.